Hello everybody. In this episode, we will be talking about an overview of machine learning. And here, myself, Dr. Neeraj Shukla, is your speaker. Now, in machine learning, the outline and content which we will be discussing is what is machine learning, learning system model, training and testing, performance, algorithms, machine learning structure, what are we seeking in this particular episode, learning techniques, applications, and conclusion. So what is machine learning? Machine learning is a branch of artificial intelligence concerned with design and development of algorithms that allow computers to evolve behaviors based on empirical data. As intelligence requires knowledge, it is necessary for the computers to acquire knowledge. So, how computers acquire knowledge? They acquire knowledge with input samples. When input samples, the system it trains, and in train it can be tested. Now, training and testing, you have firstly you go for data acquisition, and in data acquisition you get trained. That means the system get trained, and after it get trained we can test it. Now training is a process of making the system able to learn. Now there is no free lunch rule which prevails in this. Training set and testing set come from the same distribution. Need to make some assumption or bias. There are several factors affecting the performance. That means, firstly, the type of training provided. Supposingly, we have given 10,000 data, or we have given only merely 100 data. So, it depends how much training the system is going. The form and extent of any initial background knowledge, the type of feedback provided, learning algorithm which is used. Now there are two important factors. First is modeling, second is optimization. The success of machine learning system also depends on algorithm which we are using. In the particular case, the algorithm controls the search to find and build the knowledge structure. The learning algorithm should extract useful information from training sample. Now these algorithms, they can be categorized in supervised learning, where you go for prediction or you go for classification. Unsupervised learning, that is clustering, probability distribution estimation, finding association, and dimension reduction. Semi-supervised learning and reinforced learning, where you go for robot, chess or something. Now, supervised learning, you can go for classification of different kind of values. Unsupervised learning, you go for n number of clusters, because you don't know how many classes are there. Semi-supervised learning is the mix of the above two. Now in supervised learning, you have training text, documents, image or sound, any one of these. So you get a feature vector, you get labels, and you have machine learning algorithms. So either you get a predictive model. Okay, so when you go for a new set of either text, document or image, again you go for a feature vector, but now the model is trained, so it will give you some kind of result. Unsupervised learning is simply you are modeling. That means you are either creating some clusters and then you are classifying or finding a likelihood or finding the cluster ID to which this particular thing belong. Now supervised learning, low E count or maximum probabilistic term. Unsupervised learning, minimum quantization error, minimum distance. So we are seeking these. So you can see here, if you go for underfitting or if you go for overfitting, you will not get the desired result. So you should go for exact fitting. Now learning techniques are, if you go for supervised learning, they are linear classifier, numeric functions are there, parametric, probabilistic functions are there. Examples are naive Bayes, Gaussian discriminant analysis, hidden Markov, probabilistic graphical models. Non-parametrics are k-nearest neighbor, kernel regression, kernel density estimation, and local regression. Non-metrics are classification of regression T or aggregation. Linear techniques, linear classifier, that means you have a linear regression. You can use perceptron, logistic regression, support vector machine, add a line, or MLP. You can see here perceptron learning algorithm. Here is an example of logistic regression. Now if you go for a non-linear case, you have a support vector machine which is non-linear to linear, feature transform and kernel function. Learning techniques, unsupervised, if you go for, you have clustering. In unsupervised, in clustering you have k-means clustering, spectral clustering, density estimation which is GMM, graphical modes, dimensionality reduction which is PCA or factor analysis. Now application of machine learning is face detection, object detection recognition, image segmentation, multimedia event creation, economical and commercial uses. We have a simple overview of some techniques and algorithms in machine learning. Furthermore, there are more and more techniques apply machine learning as a solution. In future, machine learning will play an important role in our daily life. Thank you.